but of course, and that's how we make sure you're on track. So I'll check about the badge. I believe there is a badge for the IO event as well if you went to that one. But this in this course, the Cloud Skill Boost profile is the important one. I see we have more people joining. That's fantastic. Will all of us get the exams? So everybody who attends the sessions and fulfills all the labs and all the badges and all the tutorials, basically everything in the machine learning journey, will get a voucher to take the exam, which is, I believe, it's about $200 worth. Let me take a moment to find the learning journey to share here. Roya, do you have any comments, any suggestions, anything before while we wait for people to join and we start with Shilpa's session first?
Nothing from my end. I just wanted to welcome Shilpa. I'm for one amazed to be in a stage that she's going to speak at. She had the grant stage of IO, and just for everybody else to know, she has been working with NASA prior to joining Google. So we are all going to really learn from her. So welcome, Shilpa. Thank you for joining us here.
Oh, absolutely. Well, welcome.
Yeah, thank you so much. Happy to be here. Should we go ahead and get started? And maybe I can share my screen, or are we still waiting on more people?
Yes, please share your screen.
Okay,
That would
great.
be helpful. You can yeah, that's good to have some kind of a preview of what's happening.
Yeah, of course. And in the chat, I will type in the link for today. So, one second. Let me just copy and paste it. So, within the chat, I sent a link called developers.generativeai.google. And today, if you want to follow along or read more as I kind of present and talk about the different PaLM APIs that I've been working on, this is definitely the link to do that. And so when you get to this page, there will be a top nav bar, and you want to go to products, and then in the drop down it should say PaLM API. So it'll look like that. And then from there, yeah, once you click PaLM API, there's a part of it called Read the Guides. You can go ahead and click on that. If you'd like to request an API key, you can also do that. It's totally up to you how you'd like to follow along, but I'll go ahead and get into the presentation. Okay, and I hope you all can see my screen. I'll switch to slideshow mode.
I can see the screen.
Okay, perfect. Okay, so yeah, so PaLM API demos. The last few months at Google, I've been working on open sourcing the PaLM family of large language models, and today I'll be introducing 3 APIs that I've been touching and kind of working on. So before I get started, I'll talk a little bit about what generative AI is. Generative AI is essentially a type of ML algorithm or artificial intelligence that learns patterns from existing data, and it can be a large amount of data. And then from the patterns that it learns, it is able to generate new data. So it's able to generate text, like in the case of LLMs, which we'll discuss today. You can think images, like with Stable Diffusion, perhaps sound. And those are just a couple of examples of the types of data that you can produce using generative AI. And then more specifically, what is an LLM? So large language models are types of machine learning models that are created from being trained on a large amount of documents. Like the scale of this is very large, very expensive to train, very time consuming, and requires very good like state of the art hardware, I think, to almost like train. So it's a very extensive process. But the point of producing these LLMs that have seen so many different patterns and examples is to produce various outputs for natural language processing or NLP tasks. And this includes text generation, Q&A answering, say you have like a virtual assistant or a chatbot, and machine translation. So PaLM API more specifically, basically it is like what is in the PaLM API. So I think there's like about 4 key features. First of all, we have to discuss the state-of-the-art LLMs that are made available through the PaLM API. And so what this API does is that it allows developers to kind of like take these models off the shelf. And it's up to you if you would like to train it further, but you can definitely use it off the shelf and like apply it to your existing applications. And next is the chat service. So what the chat service does is it engages users in a back and forth type of conversation that's aware of the context. So like chatbots or virtual assistants that you might be answering questions to. And then next is the text service. So you can obtain auto completions to like different queries that you put in. Like think about on your phone kind of how it predicts the next word. So that's a potential task you could do here. You can generate summaries. You can also do Q&A here. You can ask a question and receive an answer. And one of the things is that it's able to perform tasks that aren't back and forth. So that's a key distinction from the chat service. And then finally, embeddings, which I've spent the most time on. They basically are there to convert text or like unstructured data into numerical vectors. So you can embed words, phrases, and sentences. And then the different types of use cases for chat and text, you can potentially generate your own data set. So you can do data synthesis with the chat service and the text completion. So you can produce like different types of like questions from the chat service, and you can take those questions, use them in the text service, and get answers. So that's one potential way to go about it. There are obviously like other ways to do data synthesis. You can perform text summarization, and you can build chatbots, virtual assistants, so chat applications. One interesting thing that I'll bring up later is you could potentially use the chat service, say in a video game that you're trying to create. If you want your character to speak a certain way or respond a certain way, you can kind of prime your LLM to respond a certain way. But I'll explain that a little bit further later. And then use cases for embeddings include document search, clustering, anomaly detection, and recommendation systems. So I'll get into the first service. So the chat service, like I've mentioned, it gives you a conversational response, that back and forth feeling. And let me switch over to the demo. So if you've gone to read the guides from the link that I've shared, and you go on one of the nav bars that you can scroll down on, you go to Quick Starts. And let me actually share this tab that I'm looking at instead. So essentially, just to make sure everyone's on the same page, I went to read the guides, and I went to Quick Starts, and I have text chat embeddings. So I'll go ahead and pull up chat. It's up to you which view that you would like to use. You can view it on this web page. You can run it in Google Colab. You can view it on GitHub. I think for the sake of simplicity today and to just be mindful of time, I won't actually be live running this, but you can certainly like follow along and live run it. You might need an API key, but if you already have one, you can input it, follow along. If not, there's within the guide too, there's ways that you can create an API key. Okay, but to get started with the chat quick start, I'll zoom in a little bit. And another important thing is right now we only have the PaLM API available in the US, but and that's due to just safety features and those are still being developed for different languages. But I guess to get started, this is how you would install the PaLM API Python library. So pip install Google-generative AI, and then I imported it as import Google.generative AI as PaLM. And then this is how I input my API key, which you can see there's a link to do that here. And let's finally get to the actual API call. So here for the chat service, very simple. It's just pom.chat, and within it, I'm passing in a parameter called messages. And right now I've passed a string, but I think it's important to also note that I could have passed in a list of strings. I could have passed in a dictionary, a tuple. I could have passed in multiple strings, longer string. And the point of that is that we tried to design this API to be able to receive multiple types of inputs and be flexible with the data structure and how it parses it. So yeah, I've created the chat object, which I've called response, from passing in this message. And in order to see the model's response, I do response.last, and it gives me the model's response. And it's, hello, how can I help you today? If I want to continue this conversation, I can send a reply. And taking the response or chat object, I would do response.reply, say just chilling, and then I would see the model's response again. So last will always contain the model's last response. That's one way you can remember it a little bit intuitively. And you see it's given me a response like, that's great. And yeah, that's just a very simple example of how to have a conversation with the LLM. But you can also view your conversation history. So you can do response.messages, and you can see the author and then the content. So author 0 is you. You're the first person who started the chat, and then author 1 is the model, and you can see like everything that's been said so far here. And again, this is that back and forth exchange. And then additionally, you can also choose an alternative response. Say for whatever reason you want more options of what type of response to select. So, and the reason why this is important is I should mention LLMs, depending on how they're initialized when you call them and how they're trained continuously, so the responses that you receive can change day to day. By what degree they change really depends on your input. So that's something to keep in mind and just try different things. But there's a degree of randomness produced by all LLMs. So if you say want alternative responses, you can pass in a parameter called candidate count. And right here, I've called the chat API. I have my message that I've passed in here. What should I eat for dinner tonight? List a few options. And candidate count equals 4. And then I'm going to first view the model's default response. So it says here are a few options for dinner tonight, pasta, and it's kind of describing like what kind of pasta I can have. But if I want to see all the contents, I can do response.candidates. And, you get a list of dictionaries with the author and content keys, and it can see like the different responses. And there's a little bit of repetition in how it's like phrased, but you can kind of see maybe, this way it's describing pasta as a classic dinner, and then pasta as a quick and easy meal, and then there's chicken and rice and chicken and vegetables. And yeah, they're all like kind of distinct responses. And another important thing to point out is, say you put in a candidate count of 5, but you only get 3 unique responses. It is possible to get duplicates. It is possible to receive fewer answers, and this can happen when responses are filtered or unsafe. And that's just a part of using LLMs, is that you might not get your desired outcome right away. And that's where things like training or using these, like depending on what kind of message you pass in, like that kind of the concept of prompt engineering might be useful to you. And last but not least, here's a way to change the model's default response. So response.last, let's say I like one of the other responses better, I can set that here. And so this updates your preferred candidate message in the conversation history, so it'll alter that. And then I'll introduce the concept of temperature. Temperature controls the randomness of your output. Temperature of 0 does get rid of like most of the randomness in the way models are generated. And then the model will kind of act the same in that initialization of it to every time you pass in the same message, you might get like the same response. Yeah, so always generating the same response for the same input text. And then as a result, you can only generate a single candidate for each message input. But if I set it to 1, it might give me more interesting responses. So here it's getting a little more creative. It's suggesting that I have a salad with grilled chicken or fish, a stir fry with vegetables or tofu or chicken, a pasta dish, a bowl of soup, sandwich, etc., etc. And you can see like that response right here in its description is a little more descriptive than just saying pasta. So that's one example of how the temperature parameter can be used. And then the last parameter I would like to go over is the context. So what context does is that if I say, going back to how I was saying earlier about like video games and maybe you want a character to speak a certain way or respond a certain way, you can prime an LLM by giving it some context. So if the context I pass in is speak like Shakespeare, and then I say hello to it, it gives me a very Shakespearean response. But that's not the only way. It doesn't always have to talk like someone. It can also answer everything with a haiku, following the 5-7 rhyme syllable rhyme pattern. And then I say, how's it going? And then it does that. It writes a haiku in response, right? So I can also be a little bit more vague. It doesn't have to be an actual person or anything like that. So I could say, be an alien that lives on one of Jupiter's moons. And if I say, how's it going? It starts describing the alien's like beautiful view of Jupiter from its moon. Atmosphere is very thin, and you can see the stars clearly. So you can see like maybe how creative it is. And then there's a couple more examples like listed here. And oh, I should mention, yeah, you can pass in an examples parameter. So you can, I guess, I want to use the word fine tuning, but I feel like that's a little bit loaded. So let's just say I want to prime the model. I think prime is a better word here. I want to prime it with maybe how to respond. And right here, I've given it like a hypothetical, let's say user input, and then I've given it a response, kind of in the form of a tuple, a list of tuples right here. And it's supposed to act like a motivational coach. So it's saying, what's up? Or like, I'm kind of bored. And it's like, how can you be bored when there's so many fun, exciting experiences to be had? And then basically, I pass in the examples here. And the context is be a motivational coach that's very inspiring. And it says, I understand that you're feeling very tired today. Sometimes I find it hard to get the motivation to go to the gym, but I'm here to tell you you can do it. And that's a little bit different than just generically saying, I'm excited to be able to help people with their goals and dreams. Like, it's kind of talking to you like it is a motivational coach. So yeah, that is pretty much the introduction to the chat API. I will switch over to discussing the text generation API. So text generation is a little bit different. It does not give you that back and forth kind of conversational aspect that the chat service does. And another thing about it is that you can, like the chat service, generate multiple responses. So let me switch over to showing the chat service. Go here, and you can actually go to this drop down and you'll see Python. Yeah, we have it available in other languages, but I'm just using Python for today. And like before, here's the installation API key. And then, one best practice that I think is worth mentioning is when you're building one of these applications, it's a good practice to use like one consistent model. And then basically from there, you want to make sure that by using the same model again and again, you're developing a better application because you can kind of assess the model performance in that sense. So here I've picked just the first model that came up that supports the action of generating text. So I've done that here. I've received the text bison model. And then the API for text generation is just simply pom.generate_text. And the parameter that it takes in is the prompt. So here I have a description of the word problem. I'm asking the LLM to solve this problem. I'm asking it to think about it step by step and show its work. So the parameters for the generate text API, you have to pass in the name of the model, the prompt, and then optionally the temperature and the max output tokens, which will be the length of your response. For sure, you need the model and prompt. The rest of the parameters are like, they have their own default options, so you don't necessarily like need them, but definitely the model and prompt is what you need. And then to see the result that the model produces, you would do completion.result. So it's kind of, I won't read this entire thing out loud, but you can kind of scroll through and see how it solved the problem. And it's writing down its equations, like it's showing its work, and it's giving the answer, which is, that's pretty decent. That's what I asked the model to do. And then there's also a few other arguments worth mentioning. One such argument is stop sequences. And I think while we're on the topic of word problems, it's important to mention that LLMs have been a bit notorious for making mistakes in their arithmetic. So you can use stop sequences. For example, like you could ask the model to use a calculator by putting equations in a calc tag. So I would have the model generate text up to a closing tag, and then I can kind of edit the prompt from there. So let's see. So I have given it the prompt here. Please solve the following problem for me. And I have passed this prompt into another text generation object called completion. But here you can see I passed in the additional parameter of stop sequences. And this is a list. It's possible to have more than one stop sequences. It just depends on like what kind of application you're working on. And then from that, I ask it to generate text based on the prompt up to here. And then I ask it to solve the equation right here. So I'm returning a response and equation from the completion.result, and it's being split by the calc tag. And this is syntactically how you would do it. And you can see like the response I printed out here, the chain of thought, basically it's explaining the word problem, and then I printed out the equation. And then from here, I can calculate the result. And using kind of these variables like response and equation, I can assemble a new prompt for the model to continue from. But if you would like a more worked out example of this that's specifically focusing on using LLMs to solve math problems, you should check out the text calculator example, which we have linked here. And then I can talk a little bit about candidates. It's really similar to in the chat service, how you could pass in a number for the candidate count. And I think here, yep, we've said the candidate count is 8. It's the number of responses. And you get the default response by just doing completion.result. But if I want to see the entire candidates, I could do completion.candidates. And yeah, I get the output and basically the different safety ratings, like the probability of it belonging to a safety category or having any kind of issues, like let's say like derogatory, toxicity, violence, etc., etc. So it belonging to any of these categories, that's what you see there. But yeah, I get like different outputs. I'll let you all scroll through that. And yeah, I think that's it for text generation. Let me switch over to explaining embeddings. Okay, so yes, let's see. Yeah, embeddings, like I mentioned before, are numerical representations of text. And basically you would want to use text, like say you want to embed a text and then you feed it into a machine learning model for whatever you're working on. So that's one way you can think about it. And let me jump into the kind of code part of it. So if you go to embeddings under Quick Start and you go to Python, you can see this, and then yeah, the setup, you have all already seen that. And then yeah, so I'll give a bit more of a in-depth explanation of embeddings. So you can represent words, sentences, or entire paragraphs using floating point numbers in an array or a vector. And these numbers aren't random. The key idea is that text with similar meaning will have similar embeddings. And you can use the relationship or the similarity measure between them for many important tasks. Like let's say Q&A, like you're doing maybe like a web search or a document search of, you have like some query and then you embed the query and you embed the documents. You can compare their numerical representation to find answers, for example. But I think that will become like more concrete once I go a little bit more into embedding. So I'll go ahead and do that. Similar practice as before. The name of the API call here is pom.generateEmbeddings. I choose a consistent model. This time, if the supported action is embed text, I choose it. And you can see like the list of supported generation methods if you just print that. But yeah, so this is the model I've chosen here. And then I want to use the API and pass in the model as well as the text. And yeah, like from that, I get a floating point value. So it gets returned as a dictionary that says embedding, and then these are the actual embeddings for it. So the first text I try to embed is what do squirrels eat? And then what I thought was the answer to this was nuts and acorns. And then a piece of text that's completely different is this morning I woke up in San Francisco and I took a walk to the Bay Bridge. It was a good sunny morning with no fog. And I've given it the model name. And for each of these texts, I've created embedding. So embedding X, embedding close to X, embedding different from X. And I've done that by passing in the model name and the text here. So yeah, again, this is what embeddings look like. And how I assess the similarity between embeddings. So embeddings are essentially vectors. So I kind of drew from like some linear algebra concepts to help me out here. So one such measure you can use is the dot product. I know another measure is similarity, cosine similarity. So up to you how you want to evaluate maybe how similar your vectors are, but for my case, I just use the dot product, and the dot product is essentially a measure of how aligned two vectors are. So a value of -1 means that vectors are pointing in the opposite directions, and a value of 0 means that the vectors are perpendicular, and a value that's 1 or close to even 1 that means the vectors are very aligned, they're very similar. So I use the dot product to compare the embeddings between the first piece of text and the answer that I thought was right, and I get 0.73, so not too bad. The range of these values will always return something between -1 and 1, so I think with that, keeping that in mind, 0.73 is not bad in terms of a similarity score. And then I'm going to compare it to what I thought was different. And I do this and I get 0.43. So you can see that the embeddings derived here show that there is some correlation, there is some relation between those two strings. So what can you do with embeddings actually? So you can do quite a lot. You can do search like I've talked about. you can use them in recommendation systems. So in collaborative filtering, like among your users, say like user 1 likes certain types of articles and user 2 has liked like similar articles, you can kind of recommend things that user 1 has clicked on to user 2. You can use them in clustering and in particular anomaly detection. So I actually have a bunch of tutorials that I've written here under examples so you can kind of see. And I think today I'll be discussing document Q&A. That's kind of like the Hello World easy example, but each example after that increases in complexity. But so clustering is really interesting. Like, let's say you're doing maybe some anomaly detection or like you want to clean your data set using clustering. It's really great because what you can do is you can embed your text, you can apply dimensionality reduction, which I explain in, I think, both of these, clustering and anomaly detection. It's been a while since I wrote them, but it should be contained, like the steps to doing dimensionality reduction in there. And from there, you can kind of like, based on your data set some radius or like set some like like how many outliers there are. And you can see like based on how you've plotted the reduced like components of the original data, you can see, which points are outliers. And then if you write additional scaffolding code, you can map back to the original data set, like, oh, like why is this data point an outlier? And a really common use case I like to give for this, say you're dealing with product reviews and say the specific category you're looking at is books. But for whatever reason, in one of the reviews, someone starts talking about electronics. So that would be an example of an anomaly in that data set. And you could use clustering and embeddings to help you pinpoint what those points are. And it's up to you from there what you will do with the anomalous data. And then another cool thing is that you can actually use embeddings in text classification. So you can initialize the weights of your neural network to use the embeddings, the meaning of the embeddings, and yeah, from there you can classify text that way. I explained that a bit more in the text classifier tutorial, but let me go ahead and present the simpler example for today. Okay, so I've gone to document Q&A or document search with embeddings. And yeah, I'll go ahead and get into it. So I've done the imports here, got the API key, similar practice as before. I've selected one consistent model. And now I'll talk about, well, I've already talked a little bit about embedding generation. So for the interest of time, I will just go to this section where the tutorial really begins. So building an embeddings database. So my preferred way of viewing data is through a data frame. But if there are other libraries you can use, that's also like valid. I use pandas to kind of display like my work and keep track of it. But I have created 3 documents right here about a fictional Google car. And it's a lot of stuff. So one of them is talking about different features that the car has. One is talking about a climate control system, and another one is talking about shifting gears. But I make a list of these documents, and then I'm putting them into a data frame like this. And I'm calling this column text, and yeah, it's a little weirdly aligned in this format, but you can kind of see what's happening there. And then from here, I am getting the embeddings for each document, and I'm also putting them in my data frame. So this is the result. This is a list of floating point integers. And then document search with Q&A. Okay, so I want to ask my database a question. So I give it a query, how do you shift gears in the Google car? And then what I need to do is I need to first search for the best passage to that question. And how do I do that? I do that using the dot product. I embed the query and then I compare it with the embeddings in my data frame by taking the dot product of each. And then I return the item from my data frame that was most similar to the embedding or the query embedding. So right here, I found the best passage that seems to be document 3 from earlier. And then now I'm going to build the Q&A application. So I think I mentioned a little bit before about how you can use text generation for Q&A, and that's what I chose to do here. So in order to use the generate text API, I need to create a prompt first. So I've done a lot of string parsing and basically formatting the prompt right here and kind of doing some prompt engineering in a way. I'm saying you're a helpful and informative bot that answers questions. You might be talking to a non-technical audience, so be sure to break down complex concepts. If the passage that you see is irrelevant to the answer, you can ignore it. So I'm going to create the prompt by passing the query and the relevant passage I found, and this is the prompt that I've generated. I'm giving it I'm priming it on like what I want it to do. And then, yeah, I've chosen one of the PaLM text generation models here, and then I generate an answer using the generate text API. So I passed in prompt, text model. I wanted to produce 3 candidates. I gave it like a temperature of 0.5, so not completely the same answer every time, but not completely random, kind of somewhere in the middle. And then max output tokens. And then from here, I've printed each response. And you can see like the responses are pretty similar. I think it's because the document that I use, maybe it's too short, or like this is just kind of a very simple example, but I hope by demonstrating this, I can show how you could potentially scale your own applications using the PaLM API. So take this as kind of like the Hello World example, and it's possible that you can build on it. I'm trying to think of common questions that I get about the embedding API, and one of them is like, oh, I have run into a runtime error, like, and my code stopped running, and it says that I have run this API for a maximum number of times in a session. So the suggestion or workaround I have for that before even like purchasing like say a model that can compute more embeddings is to try putting your code into try catch block and using a timer to kind of wait like maybe 10 seconds every time you produce an embedding. It's a little bit slower, but you can get the job done without having to pay. That's kind of the trade-off. Core API from Google that I think I could show. And I'm looking at the text classifier with embeddings because we included it there. Yeah. So this block right here. I've made a embedding function, and I've added this decorator right here with retry. And let's say the PaLM API has run for a while, but it runs to like complete failure, like it cannot produce any more embeddings. In the call stack trace, I'll go back to this function, I'll wait 300 seconds, and then continue running where I left off. So another time-consuming way, but just another workaround to a problem I've heard a little bit in the last like month and a half as I've been presenting. Let me switch back over to the slides. So I think that's about it from me. Here are some more resources for the stuff I've talked about today. You can check out the prompt gallery if you're interested in like potential ideas for prompt engineering. You can check out MakerSuite. I think of our like low code, no code option for using LLMs. And there's links to Google I/O. And the first link here is the link that I gave before with the guides. But I think that's it from me. So I can maybe take a couple questions.
Thank you, Shilpa. This is fascinating. We'd love to have you back and do more in-depth demos. Super, super helpful. I believe there was one question in the Q&A.
Yeah,
Is there a
let
way
me
to
see.
limit the responses returned from chat within a specific domain and reject other prompts? Would that be done through context priming both? If you go to the Q&A,
Oh, the
it's
Q&A.
there. In
That's
the chat, there's general and then there's
Oh,
Q&A.
okay, I
Yeah.
see it. Yes. Okay, perfect. I will read the question one more time. Um, is there a way to limit the responses returned from the chat within a specific domain and reject other prompts? Would it be done through context, priming, or both? I think this is something you could use both. I think my first guess here would be if you're trying to limit it to a specific domain, give it a context. You can be like, you know about only this topic, you don't know about any other topics. Like that is kind of the character that you play. Like that's how I would think about it. But I'm sure you can also prime it with examples, like say you're trying to gear it towards answering a certain way. You could prime it using like the examples parameter that I showed at the bottom of the chat service API quick start, and its potential to do it with both. So, as vague as an answer it might be, my suggestion is to try it and try both, try one, and see how that works on the model. Okay, so the next question: is there a good way to do function calling like OpenAI has, like in a chatbot, to have the model call a get weather function and answer a question about weather? Okay, so I personally am not familiar with that with OpenAI all that much, or ChatGPT. Um, so I can't answer that question, but it seems like the model call a function called getWeather and answer a question about the weather. Yeah, unfortunately, I don't think I can answer that question simply because I'm not too familiar with OpenAI. Um, yeah, okay. I'll move on to the next question. What is the training data for PaLM? So according to the PaLM paper, and from what I've heard, I think 50% of it comes from social media. And another interesting comment I got about that is because it comes from social media, is there any bias? And it's possible, yes, but the type of training or the vast amount of data that it's seen, I think the LLM has seen like different opinions, viewpoints, different tones regarding like topics, and it doesn't always have to be like charged topics. It can be like everyday topics. So, yeah, I think 50% of the content comes from social media. I think the Palm paper might say where the rest of the data came from. I cannot remember off the top of my head right now. And then will I be able to instruction tune the models for Palm? I'm not 100% sure I know what instruction tuning means. Is that like fine tuning or is that different?
I was actually typing it. It's actually fine tuning to a specific task.
Okay, I see, I see. So, one thing that we're working on at Google is creating a fine-tuning API for Palm. So that is a feature that will be available at some point in the future. But currently, I would say the best way to kind of tune your models is through context for now and feeding it different examples. And then, okay, how many parameters does Palm 2 have? Palm 2. So I am not familiar with Palm 2 as much. Yeah, that Palm 2 seems a little bit different than what I work on, so I don't think I can answer that question. I'm sorry. Are we allowed to use Palm API to build public consumer facing products powered by Palm? I think you can, but I think that's more of a question for maybe like the model compute that you purchase. Yeah, but I don't see why you wouldn't be able to use it for like public domain tasks or consumer facing products. I think the packaging or the pricing for enterprises, I think it's like listed somewhere on Cloud's website. And then what is the difference between this API and the PaLM API available through Google Cloud's Vertex AI? Oh, so they're very, very similar. I don't know the finer grain specifics, but I do know one big thing right now is that Google Cloud's Vertex AI and the PaLM APIs it offers through that. Uh, First of all, you can use it in the cloud, so that's a big thing. So PaLM API is kind of like separate. Like as you can see, the Jupyter notebooks or the collabs that I had, I was kind of you could run them locally on like a machine, and you could just import the package. Whereas I think the cloud, using the cloud models, I think there's extra features about like compute resources. And I think another thing is that those cloud APIs from Vertex are available in multiple different countries, while the PaLM API isn't yet. So if you're outside the US and you would like to use PaLM, I would suggest going over to the Google Cloud's Vertex AI and using PaLM through there. Okay, I think that's about all the time I have today. So thank you so much for having me.
This was super. Thank you for answering all the questions and the demos. We'd love to have you back anytime.
Yeah, no problem. My pleasure.
Awesome. So we have to move on. Now, Roya can have the floor. Roya, please, let's get moving to the session 2 of the Professional Machine Learning Engineer Journey. Let me post that link to the chat where you can, I would suggest save that file. That's where you want to live. Okay.
Thank you, Miss Anna, and thank you, Shilpa, very much for the interesting tutorial. I will definitely go back and try to follow all of the steps again, and maybe we can build something. So without further ado, let's continue with our professional machine learning engineer curriculum. Last week, we studied basically week 1, Google Cloud Big Data and Machine Learning Fundamental, and also how Google does machine learning. Essentially, some of the building blocks of the machine learning and how to use Vertex AI and how to use BigQuery. This week, we're going to have a deeper dive into the machine learning and also a little bit further about TensorFlow. Both courses are a little bit, I would say, they have so much content, which I suggest to start early to be able to cover everything. Similar to prior weeks, we are going to have the course and then some questions. In this week, before we start, forgive me because I'm having some technical difficulties. Sometimes there is a lag between what I'm talking about and what you would be seeing. Yeah. So week 2 is revolving over ML problem framing, and the idea is you as a machine learning scientist, how you can get a business problem and turn it into an ML solution. Basically, how to define this problem and how to define the business criteria to show that your ML approach is actually working. A part of it is you knowing that your model is good, and the other side of it is you knowing what are the risk factors, whether you are introducing bias or there's going to be like you are losing fairness. And to be able to, from these proof of concept built on top of it to build like a pipeline for extensive use. That's one part of what what we will be discussing this week. In addition to that, we are going to also look into the ML solution architecture, how essentially we can build a reliable and a scalable machine learning solution that we can take a business problem and solve it, and what Google provides to us. Whether in software or hardware, Google has so many different platforms and facility that allows you to try and implement your ideas without really needing to invest in buying certain, let's say, devices or hardware or fancy equipment. When you are looking into your ML problem, it is a continuous and cyclic, basically process. So obviously you have this problem, this business problem, and you are trying to see how you can use it to basically how you can use ML to solve it. The first stage is you knowing the problem, and you have people who are able to solve this problem. So there is the knowledge in your company, and you want to take that knowledge and train a model to gain that knowledge to apply it in a scale. So defining the business case, use cases, and data exploration falls into problem framing and use case discovery. The next step is to data analysis and feasibility study. So for a lot of practices that people are doing, actually finding the right data is harder than actually training a person doing it. So you need to be able to actually gain enough of data that allows you to apply a machine learning solution. But if you are done with these two stages, so you know your problem and you can have enough of data, and you know that the ML would be feasible because your problem can be sorted by enough of data, then you are building this future engineering pipeline. So now you are in a stage that, okay, I want to extract my data, I want to program and code my algorithm, and then I want to obviously feature engineering with ML and continue with my ML pipeline. When you are done with the ML pipeline and you see the result, then it is time for planning to deploy it. So you want to make it in a bigger, larger scale. But also that's time for continuous monitoring of the system. And usually that's when you get disappointed because your high hope falls because when you have it in the field, it's not good as when you have it in the house and you are like training and testing with your own data. But you shouldn't be disappointed at that time, because that's why we always say ML problem is a cycle. So you go back, you see where you are failing, and you try to solve those failed cases by adjusting your data and adjusting your model. Thanks to Google, now these pipeline of methods and work, they can be done with Vertex AI building blocks. So if you have been starting working on ML, let's say in 2016, it was on you to build all of these pieces, let's say in a Jupyter notebook, and sew them together to make sure, like stitch them together and make sure that everything works coherently. Right now, Vertex AI allows you to have this unified pool of basically building blocks that you can just plug and place, especially if you are not an ML scientist. So you know the idea, but you are not essentially really interested in math behind it. So you can just go and put this building block in a right space. Using AutoML in comparison with using Vertex AI custom training allows you to even not worrying about the architecture of ML by itself. If you wanted to build a video classification problem and you want to make it for your college to identify when a shoot is happening in the basketball, then you can just go to the video API of AutoML and it does it for you. And we just had Shilpa here, which showed us how we can even go to a next step, which is not showing in this screen right now, but to use large language models to our benefit, from building chatbots to classifying text, reviews, or even clustering messages. So shout out to Google for putting all of this accessible to all of us. Yep. So going back to framing a machine learning problem, as we discussed previously, when you have this business problem, the next step for you is to identify how you can turn this business problem into an ML problem. If you recall, when we are talking about the ML problem, this is a problem that we know the input and we know the output, and we are trying to identify the path from input to the output just by introducing many data to the system, in comparison with traditional programming, which you would identify the path and you put the network with the input and you expected the output. So with your ML problem, now the question for you is, what is my input and what I'm trying to get out of it? Suppose you are working on a cancer patient. Your input would be CT images with the tumor, and your output, for example, can be whether this person has cancer or not. The next question is how you are collecting this data and what are the data that you are needing. So in the cancer patient example, you require to have basically CT scan images, and collecting the data is a part of thinking about how I want to solve this problem with ML, because a lot of problems can be solved with ML if you do have the right data in a scale. After that stage is the software problem. How do you want to make this information accessible basically to your user? How you make that API, how you make that output introduced to your user, and how they're gonna be using it, and how they are doing it today. So again, if you go back to the cancer patient, who is the user of this information? Whether I want to pass it as a hint to the radiologist, or do I want to send it to a surgeon? Whether I want to identify where the tumor is, so that would be an image, or whether I want to just have a classifier to say yes or no to make somebody have a quick response. And lastly, and most importantly, is the problem of data. How to collect data, how to analyze it, and how to react to changes. Data, always go back to data. Collecting the data is a problem by itself because data can be easily expensive, and annotating the data can be really challenging and make it extra expensive. If you are working with medical data, for example, in the US, there are a lot of checks that you have to get to be able to access those data. Privacy of the customers are always issue, and you want to respect it. So data like the location and the habit of the user is not readily available to you. So when you are trying to build a system which requires data, you need to make sure that the data is easily available and you are not breaching security or privacy of your customer. Then it's you being able to analyze it in a scale and to get meaningful information from that data. Last week, I provided you with that image of the cat, and I want you to have it in the back of your mind that your ML machine can be as smart as a cat. So if you cannot, as a person, look at the data and identify the output that you want with your sophisticated, complex brain, you cannot expect the model, no matter how complex it is, to be able to answer. Even the large language model or generative AI that today we are using, they're all learning from us. And we have been the people who built this data. We have been the people who initially generated answer to the question that we are asking AI today. So it is not, it's interpolating between all of the information that we as human um, have been producing before. If it is right now, at least in the current stage of the AI, they cannot extrapolate so much from the information. So if you as a person cannot identify the answer to the question you are asking with the input, it's hard to ask the AI to do it. As a good example of that is dealing with brain signals. For example, you are trying to identify whether a person is in a deep sleep mode or in a shallow sleep mode. You need to be able to remove all of the noise. So as a person, you can see and you can identify the person's sleep status. If you do not do that, no, whether as a person or as AI, with all of the noise, there's no way that you can identify what is happening in the person's sleep status. Okay. So passing through the three stages of ML and data, we need to be able to build a prototype. So don't go big, start small, have this proof of concept with a heuristic to have a shallow way of saying that, okay, I know where I want to go, so I just want to make it more complex. And as we just discussed, it has to be an iterative way. So start small and make it bigger and better. A simple model that just can tell you whether it's doable or not, it's way better than investing a lot of time making a complex model and training it and then being like, okay, I cannot really make it. That simple model can be anything. So for example, imagine that you want to basically build a system to predict biparental duration. And you want to have like a measure in the back of your mind that, okay, what is a good rate? For example, if I'm telling you the model's mean absolute error is 1200 seconds, would you say it's good, it's bad? How would you measure it? A good way of measurement, as I mentioned, is to have this benchmark. That benchmark essentially should not be another ML system. You can start with simple ML, but you also can have some constant or some rule of thumb or something like in back of your mind. You can just go to the information, statistical information like mean, median, or mode, or you can have some people to tell you that this is the right answer or not. If you have been, if you studied engineering, you are used to the idea that you're too far from the number that you're expecting to get. So, for example, if you're an electrical engineer, you want to know roughly what is the voltage based on the current and based on the resistance. If you know the gist of the value, you can adjust and refine around it. But if you are so far from it, there is no way of refinement. And here you really want to know what is that gist of value? What do I expect? What is a really far number? Is 1200 too far from what I'm expecting, or is fall roughly in the same neighborhood? So now if we go back to that bike example, that rough value can be an average of all of the rental that's happening based on whether maybe the peak hour, or maybe you do not even want to consider the peak hour or the more popular location. But some of these benchmarks can really help you to identify whether your model is doing a good job or you are really far from good quality performance. Everything that I have been talking so far about was close-mindedly looking into the precision and accuracy of your model. I was constantly telling that we want the model to do good and we want to have a benchmark to make sure that the model is as good as we are expecting. But there is this other domain of responsibility that we do have as ML scientists to make sure that the model that we are introducing to public is fair and explainable, and it take care of the user privacy and security. Fairness is when you are trying to make sure that your model is treating everybody fairly. So suppose there was this interesting example of a model that has been used for crime detection was biased towards certain minority, simply because when the model has been trained, maybe the data was not analyzed enough to make sure that all groups are introducing the data equally and fairly. Another interesting case is the explainability of AI. And that is for you to know why and how your model is making the decision that it does make. Interesting case here was, it was a case of cancer detection, I believe, based on skin cancer detection. And in a case of cancer, the doctor, they usually put a ruler by the side of the marker or the pigmentation on the skin that they think is actually due to the cancer. And the model picked on the ruler instead of the skin, and wherever that it found the ruler, it detected it as a cancer patient. And the accuracy was really good. But the reason that the model was picking on the right cancerous skin, it was not because of the shape or discoloration of the skin, rather it was because of the presence of that ruler. So if you want to continue with ML, then you're required to be able to have this explainability. So you first and foremost, on the top here, I have human in the loop, and never think of removing human from the loop, because you want to have this check. You want to be able to audit the data. You want to always be able to interpret the system. You want to be able to trace and make sure that it is accountable. You want to be able to see the transparency. And all of these fall under the umbrella term of explainability. And the explainability, it's not only impacting you as a scientist. It impacts you because you want to make sure that your model is working well and you want to know how to improve it. But it also impacts the end user. Right now, we are in the time of generative AI, and there are a lot of concern around how we can make sure that the end user does a good job, and how we can make sure that they get the response that they're supposed to get, and the model does not predict something out of the blue that is basically unreasonable. And also the idea that the public, we need to make sure that the system is safe. Recently, um, in Europe, they started to building regulation around AI just to make sure that the model that are uh, put out there, they are safe for everybody's use. So right now, you are not just responsible to your boss or your company. There are so many other people that can be impacted by what you are doing. For explainability of AI, you can always go back to the data and you can pinpoint what in the data uh, provokes the answer that you are getting. The idea of attention has been introduced, I believe, in 2017, and it was to pay attention what part of the model actually makes the answer that it does make. So, for example, in the case of images, you can go to the middle layer and build basically essentially a heat map to say which part of the model, which part of this image was hotter, was more significant in making the answer that it does make. In the case of semantic analysis, you can go back to the data in the image that I have in the middle and say what word was more valuable and what had more impact in the result. So, for example, here, not love made the score to go to closer to 1. And lastly, in this example of tabular data, you can go back and figure out which part of your which features have a higher impact in the response that you are getting, whether it's positive or negative. We talked about the explainability of data, but the other side of it is fairness of the system. When you are thinking about fairness, you have to go back to the data. If I have a model and I'm expecting it to just identify shoes, and I never have introduced to it, suppose cross, then it can identify all other type of shoes, but it gets confused when it sees a Crocs kind of shoes. So when you want, because the model has no idea that it is also a shoe. It can be a little bit funny, but think about Little Mermaid. And Little Mermaid didn't have any clue about the fork, so when she saw it for the first time, she didn't know it's a fork. The closest thing that she could think of was to think of it as a comb, because in her world there was no presentation for the fork, right? So for your model to be able to identify everything, you actually need to have a snippet of every piece of data that it can basically your model can come across in your training data, which is harder to do than said. Because the data is naturally biased, so you do not have incident naturally occurring at the same rate. But also, it is not to say that bias is always bad. As I mentioned, it can happen naturally. But there are also biases that are caused by data distribution and data representation. These are the type of biases that you need to be aware of. And the person who does it might have biases. In our subconscious, we tend to try to make the system work that we expect it to work. So that is another type of bias that can happen. If we put all of it together, we can say that bias happens everywhere. From collecting the data to the end part of using and interpreting the output, bias can happen. Thanks to Google, there is this amazing tool called what if tool, and it takes your data as input and tries to tell you which part of your data is actually responsible for what is happening and whether you have a fair data set. So for example, it can tell you what features have more attribution basically to the output that you are seeing. And it can tell you what happens if you are turning off a feature or turning it on, basically removing a feature, what is their impact. It is also a good tool for anomaly detection because it shows what is the distribution and it shows if you have a class imbalance. Going back to the class imbalance and biases in the data, there is, as I mentioned, there is unfair bias in the data distribution. And that is when you are not introducing all of your candidates with the same population in your data set. So for example, in this case, despite we expect to have the same number of dogs as we have the same number of cats, now we have only 20% of the data to be dogs and 80% to be cats. On the other hand, you have the naturally occurring biases. So the chances that a transaction be fraudulent is significantly lower. So for you as a developer to be able to identify those, you have to take into different type of measures to make sure that your model is sensitive enough toward the fraudulent transactions that are not happening frequent, let's say, so frequent that the model pick on them naturally. The reason that having balanced data sets, especially in the natural scenario, is important is if you have a data set that has basically a good happening 99% of the time, and you only have 1% of your data represent your second class, if your model close its eye and ignore the second class altogether and just classify everything as a first class, as a majority class, you have good enough accuracy that you pass the model. So for example, in this case that I'm showing on the screen, the majority is actually good 95% of the time. And for your minority, you are wrong 88% of the time. But because the majority is so much bigger than your minority, the overall accuracy is still 93%. And if I just come to you without any context and tell you I have a model with 93% accuracy, you will be like, okay, this is a really good model. Let's go with it. There are ways to make sure that you are handling this situation. One of them is downsampling. So by downsampling, you know that you have this majority class and you have this minority class, and you're like, okay, because my minority class is too small, I will throw out enough of my majority class that my majority class and my minority class are relatively the same size. And let me be frank with you, this is not always the best way of doing it because data is expensive. You don't want to just throw data out. Another method that you can use is upsampling. Now you have your majority class. You are generating new data to fill in the gap between the minority class and majority class. In industry, I see this a lot because, for example, if you are working with image data, TensorFlow allows you to augment your data on the go with simple changes like flipping or changing the brightness of the image, or cropping it. And that simple changes actually increases the size of your minority data. Another method that you can do is to punish your system, whether by changing your loss function to pay more attention to your minority class, or to produce or to increase the chances of picking the minority class higher than your majority class. So either in your data set, when you are introducing your data to your system, you can increase the chance of your minority class to be picked more times, or you can change your loss function to penalize if you are making a wrong answer for your minority. Both these cases are essentially changing the weight of the minority class for you. Before we start, I mentioned that you need to be able to translate your mathematical information and your basically more scientific view of the model to something that marketing and sales and the other side of the team would understand. So it's really easy for you to get deep into the model that by just looking at it and looking at the results, you know what is happening. But it's essential to be able to translate it to somebody who doesn't have that much of attachment to the system. Few of the criteria that you can introduce are precision, recall, and accuracy. Precision is true positive over actual results. So true positive plus false positive, right? Essentially, by optimizing your system to have higher precision, you are trying to lowering your false positive. So I go back to my cancer example. You do not want to tell somebody they have cancer if they do not have cancer. So you don't want to have false positive. You do not want to raise the flag and say something is happening when it is not actually happening. That's where you are optimizing for your precision. Recall, on the other hand, is true positive over true positive and false negative. So if you're optimizing for recall, you don't want to miss anything. You don't want to have any false negative. You don't want to miss a positive by saying it's negative. So in the case of COVID, you wanted to be more cautious and not to have many false negatives. Now, if you put all of your true positives and your true negatives, so everything that you made a decision about them and all of those decisions were right, together divide by everything, that is accuracy. Another measure is a harmonic, basically average between the precision and recall, which is known for F1 score. It's 2 over inverse of precision and recall. If you do all of the math, it gets to be true positive over true positive plus half of false positive and false negative. So if I go one slide back, precision was optimizing for false positive and recall was optimizing for false negative. Now F1 score, if you optimize it, you are actually reducing both false positive and false negative, which makes it harder. But it is a better measure because it considers them both. Lastly is the area under the curve and false positive rate versus false positive rate versus true positive rate and precision recall graph. These are graphs that you are building based on your threshold. So when you have a classification and you are trying to identify the true positive and false positive, there is a threshold that you can move. So for example, if you tell everybody that they are all having COVID, there is 100% chance for sure that you are catching everybody who in reality have COVID, but you are also having false positive rate of 100%. And that is the reason that true positive rate over false positive rate is 1-1, because you are catching everything. But also you are wrong about all of your negative cases. So by changing that threshold, bringing it lower, basically you are trying to figure out with that specific threshold how many right calls you are making. So the area under the curve in these scenarios, the higher the area under the curve is, the better your system would be. Between the right and the left, so the ROC curve, which is the true positive rate over false positive rate, it considers both classes, whether they are the majority class or the minority class. But precision recall pays more attention to the minority class due to the way that you are calculating it. With that being said, I'm ready to dive into the questions if you do not have any questions. And let me check your questions first. Emmanuel asked, when you are downsampling or upsampling, are you trying to clean the data needed for the training? I mean, when you downsample and upsample, are you looking for quality data and have them at the right amount? Yes, the answer is yes. So you always try to make, at least that's my experience. We have so many other professionals, I think, in the audience, and they might not agree, but I always make all of the data clear and clean and make sure there are basically no essential problems. So there is no, in the case of, let's say, tabular data, there is no NaN, there is no unrealistic number, there is no outlier from the output. Then I try to make sure that the data is not biased. Because if you do it prior to that stage, essentially you are removing some of the data, refining some of the data for all of the cases that I exampled. So you cannot guarantee that if you do your upsampling or downsampling prior to cleaning the data, that would pass into the clean data. Which lab is this lecture related to? Friends, what we are explaining here are not a one-to-one to the lab that you are going to read, and the content that you are going to see in the week 2. So I cannot just pinpoint you to that this is the lab, but we are trying to cover more information from what you would be having in the course. Okay. Miss Anna, we are at 5:30. Do you go through the sample questions, or do you want me to go through the sample question in office hours?
Well, I think we can go a few minutes over time. They don't take more than 5-10 minutes, right?
Sure. Okay, so let's dive into the sample question. I will give just like 1 minute per question. Put your answers into the chat, and then we can, I try to quickly. Question number 1, fill in the blank. Vertex AI Workbench provides 2 Jupyter Notebook-based options for your data science workflow. Blank are deep learning VM image instances that are heavily customizable and are therefore ideal for users who need a lot of control over their environment. A, user managed notebook instances, B, managed notebook instances, C, unmanaged notebook and user defined notebook, D, managed notebook and already created notebook. Please answer in a minute and we continue from. Okay, so this is an easier questions, and if you have been working with Vertex AI, you already know the answer is A. User managed notebook gives you all of the customization that you require. Second question, the data used to train a model can originate from any number of systems. For example, logs from an online service, images from a local devices, or documents scraped from the web. Which of the following is the best practice for preparing and storing unstructured data, such as images, audio, and video? BigQuery, Google Storage, Bigtable, Cloud SQL. And your 1 minute is starting now. And as your friend mentioned, the answer is B. When you are dealing with unstructured data, your choice is Google Storage. All other examples are good choices when you are dealing with a structured data. Question number 3. You work for a maintenance company and have built and trained a deep learning model that identifies defects based on thermal images of underground electrical cables. Your data set contains 10,000 images, hundreds of which contain visible defects. How should you evaluate the performance of the model on a test data set Y? Calculate AUC value, calculate the number of true positive results predicted by the model, calculate the fraction of images predicted the model to have a visible defect. D, calculate the cosine similarity to compare the model's performance on the test database to the model performance on a training database. So 1 minute. The answer is A. When I was explaining, I mentioned that the area under the curve is agnostic toward the majority and minority class. It basically tells you it doesn't fall into the minority being smaller. So like the accuracy that if the minority is smaller, it ignores it. That doesn't happen with area under the curve. The second is wrong because you are talking about the true positive rate, but because your positives are really small, as 100 over 10,000 is a tiny number that even if you miss all of them, your accuracy would still be high. And calculating the fraction of images with visible defect, basically it doesn't indicate whether your model is accurate or not. And cosine similarity is a measure for image classification. It basically finds the distance between two embeddings. So that is the reason. I have some question marks. I'm not sure whether you didn't know the answer or you are not happy with the explanation that I made. And why everybody thinks the answer is B. If you just, okay, thank you for those who explained to me, but the B is not right again, because calculating the number of true positives without basically considering the false positives it's misleading. So you are not getting the whole picture into account.
Roya, how many would you say you need to have? 1,000, or what would be the minimum number?
You always want to have them relatively the same size. So here we have such an imbalance. This is a case that you want to upsample. We are dealing with images, so you can upsample your images with defect using some sort of augmentation. Because right now, if you miss everything, you are missing 100 over 10,000. So you are losing 1%.
Right.
Even if you miss everything, you are still 99% of the time correct, because 10,000 other images are right. Make sense?
Yeah, it does, yeah.
Thank you. I think we have 2 more questions. Okay, I gave you the answer, but imagine that you didn't see it. I'm having technical difficulties. I'm sorry, guys. So you are an ML engineering at a media company. You need to build an ML model to analyze video content frame by frame, identify objects, and alert user if there is inappropriate content. Which Google Cloud product should you use to build this project? You already saw the answer, so I continue. If you listen to me when I was explaining, Google has APIs for most of the off-the-shelf problems. So in this case, for identify inappropriate content, you can directly go to Video Intelligence API, and it exactly does that for you. There are so much confusion prior to this session when I taught this course previously with why AutoML Video Intelligence is not an appropriate answer. And the reason for that is when you are working with AutoML Video Intelligence, it requires you to actually build a custom model and have your data, which makes the case more expensive for you. So the best case, the best answer here is the Video Intelligence API, simply because Google has done it already. It's like having a tool in comparison with building a tool. Last question. A sarcasm detection model was trained on 80,000 text messages. 40,000 messages sent by adults 18 years and older, and 40,000 messages sent by minors less than 18 years old. The model was then evaluated on a test set of 20% messages, sent 20,000 messages, 10,000 from adults and 10,000 from minors. The following confusion matrix shows the result for each group. A positive prediction signifies a classification of sarcastic. A negative prediction signifies a classification of not sarcastic. Choose the correct answers. So 2 answers are correct from the 4 that I'm having on the on the screen. And you have the precision and recall for the case of adults, and you have the precision and recall for the case of minors. So 1 minute and tell me which one is right. If you are answering this question, there are 2 answers that are right. Okay, the right answer is actually A and B. And I waited a little bit further. I don't know why you are falling into the pitfall of D. So I start from there. D says overall, the model performs better on example from adults than on example from minors. Overall, what you are seeing is that the model does 90.9 precision on adult and with recall of basically 93%. Whereas for the precision and recall for minors, it's 95% and 49%. But I beg you to look closer to the data. When we are in the case of the adult, the cases that have basically the adults been sarcastic is 512 true positive, so true sarcastic situation, in addition to 36 false negative. So these were sarcastic, but the model couldn't catch those. So out of the 10,000, less than 1,000 are sarcastic when the adults are talking. So obviously, when you are talking about the precision, which is the true positive over true positive plus false positive, your false positive are really small. And when you are having the true negative, your true negative are also relatively smaller. It doesn't tell you enough because your system is not balanced. It also C is the 10,000 messages sent by minor are a class imbalance data set. If you again do the same thing, so all of the positives are for minors are adding in a column. So 2,174 plus 2,177 is roughly about 4,000 something. And the minors, which were not sarcastic, if you add them, it's about 5,000 something. So they are not exactly 5,000, but they are relatively the same. So there is no imbalance in the minor. A and B are right. A is right because the 10,000 messages sent by adults are a class imbalance data set. That is correct. As I mentioned, out of the 10,000, more than 9,000 of those are adults not being sarcastic, and only about 550 of those are adults being sarcastic. So even if the model completely doesn't pick on the adults being sarcastic, it is still carrying a really good accuracy. And the model fails to classify approximately 50% of minor sarcastic messages as sarcastic. And that is the reason when you are looking into all of the sarcasm made by minors, you see that 2,100 have been caught and 2,100 hasn't been caught. So 50% are failed to classify. With that being said, we are done with the course today, and I don't see any other questions. I'm sorry if I went longer. It's like 20 minutes more. So if you had any other plan, please forgive me. Next session would be office hours. I'm available on Slack if you need any help. And 2 weeks from now, we will continue with week 3. With that being said, thanking you all, and I pass the stage to Miss Anna.
Bravo, Roya. Thank you so much. This was amazing. Yes, we are a little bit over time, but I think this was a fantastic way to spend your evening. Thank you. Then office hours are posted. You should be getting emails, of course. So make sure to sign up for that if you think it's helpful, if you have questions in the meantime. There was one question when you can catch up. So Roya can speak to this better since she's just did this, but don't fall behind. I made the mistake of not checking everyone's work every week. Last time we ran this course, and in the end, a lot of people were scrambling, and we pushed them to finish, but you simply cannot do this time. Roya has done this, and after week 3 becomes even more intense and complicated. It's just you won't have time to catch up in the last moment. So please stay on track, and we'll be keeping track as well. You should have shared your profile publicly. If not, we'll be contacting you. And that's that. This was amazing. Thank you so much, ladies. Linda, Roya. Maddie wasn't here today, but I hope you saw her message in the Slack channel. She did say she sent her greetings, and she said to please keep up. So
thank you, Anna, too. You do such a great job organizing all these study groups, and I think everybody here appreciates all your efforts, and we are very grateful.
thank you. Yes, of course. We are here for the community.
For who is looking for the videos after the event ends, you'll find the video at the top that it's hosted in YouTube. So don't worry, you'll find all the YouTubes in each event page at the top of the page. Thank you.
Yes, of course. Keep up. We have the Slack channel, and we'll see you in a week. Bye for now.
Thank you.